Hello and welcome to this lesson. Here we are going to thoroughly discuss a certain subtopics under this topic called electrochemistry. So in short, before I proceed, I know electrochemistry is a topic is one of the topics in Form 4, and electro just mean the electrons, from the word electrons, and also we have the chemistry. So here it mostly deals with the redox reaction, where a redox reaction is a reaction which in which the reduction and oxidation takes place simultaneously. And again, electrochemistry is just a branch of physical chemistry that deals with the transformation of the chemical energy to electrical energy, or the vice versa. So this is our first lesson, and your presenter or your teacher here is your tutor is teacher Stephen Omondio Kech. There is my number here. Whoever want to maybe to communicate or consult, you are highly welcomed. So the objective of the lesson, we have objectives. By the end of this lesson, the learners should be able to, one, explain an electrochemical cell in terms of electron transfer process. Again, they should be able to draw a cell diagram, that is electrochemical cell. They should be able to draw electrochemical cell, which is also known as galvanic. The galvanic, it depends with the pronunciation, the galvanic cell or voltaic cell. You should also be able to write the half-cell equations and write the soil notations. Should be able to know the functions of the salt bridge. Now, I want us to check the next slide. The next slide. That is the KCSE mapping on this topic here. The KCSE mapping on this topic, that is the KCSE mapping on electrochemistry from 2000 to 2021, mostly chemistry paper 2. So this is a topic which is highly examinable in the KCSE examinations. So if we begin with the 2000, in the year 2000, this topic was not tested. In the year 2001, the topic was tested. So the topic was tested, question number 3, that is 2001. Then if you come to 2002, it will also tested question number 4. 2003, it also was tested in question 2. In the year 2004, it was not tested. In the year 2005, it was tested in question 3. In the year 2006, it was tested question 1. In the year 2007, it was not tested. In the year 2008, it was tested question 6. The year 2009, it was tested in question 3. In the year 2010, it was tested question 1. The year 2011, it was tested. In the year 2012, it was tested. The year 2013, tested question 3. In the year 2014, it was not tested. In the year 2015, it was tested question 4. The year 2016, it was tested and it was combined with metal, which was aluminum. 2017, it was tested question 2. In the year 2018, it was also tested, but was combined with the gas law. In the year 2019, it was tested question 6. The year 2020, it was tested question 5. And lastly, that is last year, it was also tested question number 7. So if you check from the year 2008 to the year 2021, it has only missed once. So the probability of this question being tested even in this year is higher. So the students should just prepare themselves adequately enough by reading anything that maybe they should know. So in the year 2014, it was not tested since we know that paper 2 consists of 7 questions, but in the year 2014, you get that it was only tested. They only tested 6 questions. The 2007, they only tested around 5 questions. So you get that in paper 2, they always try to balance the branches of chemistry. We have physical chemistry, organic chemistry, inorganic chemistry, analytical chemistry, or we have 5 main branches of chemistry. So they always dwell among those. They try to balance. Each branch should be tested. They ensure that each branch is tested. Let us now proceed on and discuss this. So our main topic here, or main subtopic, is this subtopic known as electrochemical cell, which is also known as galvanic. So this is not there, it should be galvanic cell, which is also known as voltaic cell. So what is this galvanic cell? So the galvanic cell is just a cell, or it is a setup that transform or changes the chemical energy into electrical energy and vice versa. The galvanic cell can even be battery. For example, if we have a dry cell, this is our dry cell. Let me draw it well so that maybe you can be able to understand that. This dry cell, we have maybe a bulb here connected to it. So we have this one, then this is bulb, and it is connected to this. So this terminal is the negative terminal, and this side is the positive terminal of the battery. So in galvanic, there is that chemical energy inside it. So this chemical energy is converted to electrical energy, where it converted to electrical energy to provide useful activities. So you realize that. So the electron will now move from the negative part. Electrons moves now from the negative part towards the positive terminal, like that, as it passes through this one. And when the circuit is complete, then the bulb will now light up. So that is the dry cell is an example of galvanic cell. Even the calculator batteries, all those batteries are just galvanic cell. So how does this cell looks like? How does it looks like? For example, let's see the electrochemical cell when the half cells of the zinc and copper are connected. So we will have our first half cell this like this. Then this half cell contain the electrode which is dipped in its solution or its ion. For example, we have zinc and copper. So therefore, this side will have the zinc electrode. So this is zinc electrode, which is dipped inside what we call maybe the zinc sulfate solution. So this one can be zinc sulfate solution. That is that zinc sulfate solution. Then this side also we have another, we have this one. So in this side we'll have the copper electrode dipped into maybe copper sulfate. It's dipped inside what you call the copper sulfate. The copper sulfate. This is copper sulfate solution. So that is that. Then the two electrodes are connected by a metallic wire. It can be either copper wire. So any wire that conducts electricity. Any wire that conducts electricity. So they are connected, and there is voltmeter, which is used to determine the voltage of the cell. Like that. Then this one you have said, this is a zinc electrode, that is zinc metal, and also which is now solid because it is a metal. Then this side we have copper metal, which is now solid like that. So then the two solutions for the balance of the charge, the two solutions are connected with what we call the salt bridge. The salt bridge provides the balance of charges, which we are going to explain later. So that is our salt bridge. So the salt bridge is soaked in any soluble salt. Well, so it can be copper, not copper, but potassium nitrate, can be potassium chloride, can be sodium chloride. That is that. Then what you should also know, in this side, this one, on your left-hand side, there is what is called oxidation. The oxidation takes place there, and oxidation always takes place in the anode electrode. Therefore, this one will be anode. Anode, where the oxidation is taking place. The oxidation is taking place here. Then this side is now the cathode, where the cathode electrode is an electrode where there is a reduction cathode. So this one will be cathode. So this side, the reduction is taking place. Reduction is taking place like that. So you realize that the zinc will be oxidized while the copper itself will be reduced. So how is this one taking place? Always, you should know that the most reactive metal is always reduced. Is always oxidized. I mean, the most reactive element is oxidized. The most reactive element is oxidized. Like if you compare the reactivity of zinc and copper, you realize that zinc is more reactive, therefore it will be oxidized, while copper is less reactive according to this. Or in other words, you can compare their voltage, the volt, the standard electrode potential, of this element. Like you realize that zinc has a potential electrode of negative 0.76, while copper is having positive. So you realize that zinc is a reducing agent, while copper is an oxidizing agent. So always the oxidizing agent is always reduced, while the reducing agent is always oxidized. So if you, for example, we have said that zinc have a standard electrode of negative 0.76 volt, negative 0.76 volt, while copper has electrode potential of negative, not positive, I mean positive 0.34 volts. So always for you to understand this, the one that has got higher electrode potential is always an oxidizing agent. The one with the higher electrode potential is always an oxidizing agent. Therefore, it is always reduced. The one with the lower electrode potential is always reduced. So therefore, it undergoes what is called oxidation. So that is that. So the one that is always having the higher, or less, rather than, okay, the one that has the lower electrode potential is always placed at the right, not at the left. I mean, the left-hand side. It is always placed at the left-hand side. So the one with the lower electrode potential is placed at the left-hand side because it undergoes what is called oxidation. So here you realize that zinc is oxidized. So zinc metal is oxidized to zinc ion, and now it releases 2 electrons. So this one will tell you that now the electrons will now move from the anode to the cathode. So the electron now moves from this side. Electron now move towards the cathode, towards the cathode. is moved towards the cathode, and therefore these electrons which are moved towards this side will combine the copper ions, will combine with the copper ions inside this solution because the opposite charges attract. So always the electrons are negatively charged, and here copper ion is positively charged. So therefore, the half cell equation for this side at the cathode, the half cell equation at the cathode is 2 positive. So this 2 positive combines with the 2 electrons which are from the anode. The 2 electrons from the anode to give us what we call the copper metal, which is now solid like that. So anode, the oxidation takes place at the anode, the reduction takes place at the cathode. So like this one, how can we know that the oxidation has taken place in this half cell equation? So you realize that the oxidation of zinc metal here is 0. So, and the oxidation of zinc ion is 2 positive. So you realize that the zinc has been oxidized. There is an increase from 0 to 2 positive. So that is an oxidation. Well, the reduction here, you realize that the copper ion has 2 oxidation state of 2, while copper has oxidation of 0. So there is a reduction from 2 to 0. So this one, so you realize that this solution, the number of copper ion will reduce, making this solution to be negatively charged. So the most ion which will remain here is the sulfate ions. So these sulfate ions will again be attracted towards the anode through this, what we call the salt bridge. So for example, here in the salt bridge, we have potassium nitrate, say potassium nitrate. So what will happen? These ions, the copper ions, will now be attracted to the copper electrode because of what we call the electrons. Because electrodes are negatively charged while the copper is positively charged, so they will attract. So when they attract, the size of this electrode will now increase. There will be increase the size of the cathode electrode, hence increases its mass. In this side, because the zinc, the ions are now removed from this one, and the what you call the zinc ion also is getting away from this solution, from what we call the zinc atom from the anode, making this one to reduce in size. Therefore, the mass is also reduced. So somebody can ask you to maybe explain the observation which are made at the anode and at the cathode, or compare the masses of the anode and the cathode in this electrochemical cell. So you realize that at the cathode there is increase. There is increase in the what? In the mass of the electrode, while at the anode there is a decrease. Why? I've said that the ions, the copper ions, reacts with the electrons, making this electrode bigger and hence increases its mass. So we realize that, so in this case, so the cation, the ion The cations, which are positively charged, will now be attracted to the cathode, and this one will also be attracted to the anode, like that. So because the solution here will be positive, because we realize that this zinc ions will get out from the electrode and flows towards the salt bridge. So in this salt bridge, so the process continues until it reaches the equilibrium. So therefore, in that case, the charges shall have been balanced. So that is the function of the salt bridge. It provides the balance for the charges. So that is that. So when you are told to draw electrochemical cell, one, ensure that you show the direction, because it is always 3 marks, shows the direction of the electrons. You give the sign for the voltmeter. You ensure that in this case, the anode is always at the left hand side, while the cathode is at the right hand side. And the element with the higher electrode potential is placed at the cathode, and it is always reduced. While the one with the lower electrode potential is placed at the anode, and it is oxidized. Then you have to draw the salt bridge. You connect the two solutions using the salt bridge, and you indicate the salt. The reason why we call it a salt bridge, there is a salt. It is just it is just a piece of material which is soaked in a soluble salt. And the one which is always used here can be even filter paper and water view. So that is that. And you name it, that is a salt bridge. You name the electrodes accordingly. You should be able to do that. Then you can be told to combine the two equations. The two equations can all, to get the overall, you add the two half cells. The two half cells. The two half cells. The two half cells. This one, if you combine them, and this is always solid. This is aqueous. This is also solid aqueous, like that. So when you combine this, those electrons cancel each other. So you'll be able to get the zinc, which is solid, plus the copper ion. Copper ion to give us the zinc ion. No, to give us, sorry, the reaction arrow. You write the reaction arrow to give us the zinc ion, plus the copper metal. So this is solid. This is aqueous. And this is also aqueous. So from here, you can also be told to write a cell notation. So the cell notation, you can get it from this side or just from this. At the anode, we always begin with the anode where the oxidation taking place. And what is there at the anode is zinc. So this zinc is oxidized. So this line represents the interface of the metal and its ion. So here will be zinc, ion, zinc, ion, where this is solid, this is aqueous. Then these two half cells are connected by what is called the salt bridge. So there are two vertical lines which represent the salt bridge. Then at the cathode, there is reduction. So to me, that is copper ion. Copper ion is reduced to copper metal, which is, this is solid, and this is aqueous. Just in that manner. So this is what I wanted you to understand. When drawing the electrochemical cell, ensure that all the things that I've covered, ensure that you follow them for you to earn those 3 marks. So it was also tested last year. So be able to know that. So I want us to check a certain question. This question here. So the question reads, the standard reduction potentials for 5 half cells are shown in the table below. Study it and answer the questions that follow. The letters do not represent the actual symbols of the elements. So we have this A, which is reduced to that. So how do you know that an equation is a reduction equation? When the electrons are on your left hand side, that is an oxidation. When it is on your left hand side, it is a reduction, sorry. When it is on your left hand side, that is a reduction reaction. But when it is in your right hand side, it is an oxidation reaction. So you should be able to know that. So we have all these ones. So this one has been reduced to this. This one has been reduced to this. This one also has been reduced to this. This also has been reduced to that. Then before we go there, what should come to your mind? The positive one, which means add, that is oxidation. That is now oxidizing agent. Because they are always from potassium to around lead. Those are the negative ones, which are reducing agents. Then there is an interface one, which is now hydrogen with the 0.00. So below hydrogen, those are oxidizing agents. So like this one, I've said positive one, the word positive is to add. So that is oxidizing agent. The one with the negatives, negative me to remove from the word subtract. So that is reducing agents. Then we have The positive one, I've said the positive one from the word positive, add, which is now oxidizing agents. The negative one, remove or subtract, that is reducing agents. So how do you know that this one is the strongest reducing agent and this one is the least reducing agent or the lowest reducing agent? The one with the one which is mostly positive, the most positive one is always the strongest oxidizing agent, while the most negative one is always the strongest reducing agent. So for example, if you ask to identify the strongest reducing agent here, the equation or the element which is the strongest reducing agent is this R2 positive. That is the strongest reducing agent because it is the most negative one. Then the strongest oxidizing agent will be now the A2, that is the most oxidizing agent because it has higher the higher standard electrode potential and that. So let's come to the equations. The first equation, with a reason, identify the strongest reducing agent. So the strongest reducing, the word reduce, you underline this one. The one that you underline first is reduced. Then you say reduced is remove. Then the strongest one is the one that has the higher negative. Then you just come and identify it from this one. From this, so the most negative one, so you will come and select this one as your most reducing agent because it has the higher negative electrode potential. Very good. Then the next question, write an equation for the cell formed when Q and Y half cells are rejoined. So when you write the equation, when this one, so when Q and Y are rejoined, so we have this Q and Y, Q and Y, this one. So when you ask such a question, let me delete this one so that we can be able to, when you ask such a question, Q and Y, sorry, it was Q and Y, this one, Q and Y. So if you ask such a question, you first identify the most, if you draw the half cell, not the half cell, but the electrochemical cell, which one is reduced here and which one will undergoes oxidation and which one will undergoes reduction. We said that the one with we said the negative one are reducing agents. So the reducing agents means they are now oxidized. Then the positive ones are oxidizing agent, therefore they are reduced. So this one will be at the anode. So in anode always is the negative terminal in electrochemical cell. So that is maybe the confusion. The anode in electrochemical cell, it is a negative electrode where the oxidation takes place. So this one, this Q will be at the anode because it will be oxidized since it is a reducing agent. Then it will now reduce this one. It will now reduce that. So to me now, we'll have Q which is oxidized. So you will begin with Q which is solid plus, not plus, but to give Q ions which is aqueous plus the two electrons, so like that. Then we have Y. Y will now, the Y will be reduced. Here is positive. Y will be reduced. Q will be oxidized while Y will be reduced. So if Y will be reduced, that is the two electrons here combines with the Y ions, the Y ions, the two electrons, to give us the Y solid. Y solid. So like this is aqueous. So realize that this one has been reduced to that. Then this one had a potential of negative 0.13. This one had a positive 0.34, like that. So therefore now you add these two equations, where this one will go with that. So we'll be able to get, let me write it up here. We'll be able to get Q which is Q which is solid plus Y ion, 2 ion, which is aqueous, to give us what is called to give us Q ion, to give us Q ion, 2 ion, which is now aqueous, plus a Y metal solid. Then you come and write electropotential, which you will now add them. So if you add the electrode potential, you will be able to if you add this plus this, or in other words, you can use this formula which says that oxidized minus reduced. So the oxidized is this one. You subtract reduced, which will be 0.34 minus 0.12, like that. Get this. Say that reduced minus oxidized. The reduced one, is this Y. Oxidized is this Q. So it will be 0.34 minus 0.12, which will be 0.34 plus 0.12, which is equals to 0.46. You must write that charge. Now it is positive. For the reaction to take place, the E volt must be positive. If it is negative, then there is no reaction taking place. So that is that. The next one, calculate the EMF. Calculate the EMF in calculate the EMF of the cell in Roman 2. It should be 2. Roman 2 here. The one that we have done here. In fact, we have calculated it. We have said that it is the electrode potential of reduced minus electrode potential of the oxidized one. So the reduced one was 0.34, which was positive, minus 0.12, which now if negative and negative is positive, so if it will be 0.34 plus now 0.12, which is the same as of 0.46 V. Upper is positive. You have to write that, the charge and then the unit. Thank you very much. Let's see this, the last one. The diagram below represents a mercury cell that can be used in industrial manufacture of sodium hydroxide. Study it and answer the questions that follow. So what do you understand here? What you must understand, the mercury cell. The mercury cell is used to manufacture sodium hydroxide. So this is how this works. We know that the raw material which is used here is the brine. And this brine is made up of sodium chloride. Sodium chloride. And in the cell of the mercury cell, we have what is called the graphite anode. The anode is made up of the graphite. So the brine is concentrated sodium chloride. But when we electrolyze this one, we know very well that we will have at the anode where the reduction, the oxidation is taking place, we'll have two ions, which is chloride ion and the hydroxyl ion. The hydroxyl ion is from water because it is sodium chloride dissolves in water, concentrated one. Then at the cathode, we know that there is oxidation, reduction, which is the cathode. There is reduction. So where we will have two ions which are positively charged, the the hydrogen ion and the sodium ion. So here at the anode, chloride ion is preferred. It is now the preferential ion over these two ions. If you come to cathode, the hydrogen is the preferential ion in this case. So for us to remain with sodium ion, this one, now the cathode will be made up of what is called the mercury. So the cathode will be made up of what is called the mercury. For us to now, because the mercury has a lower tendency, the lower tendency that will make it to attract this is what we call the sodium ion. So that is why if you check here, it is made up of graphite. So the graphite, we know that chlorine will be attached there, the chloride ion. Then here, this one, the steel, here is now made up of what we call the mercury ion, where the sodium ion will be attracted there. Then we know that mercury has higher, or it is more dense. So therefore, it will now settle down here. Then the brine will be up here. The brine will be up there. So there will be interface. This one, because mercury is down, then the brine is up there. Then this brine should continue moving. It should continue moving to ensure that there is high concentration of sodium ion and the chloride ion. Then it will move, it will circulate as it move out. Inaingia hivi, it gets in and gets out this side. Then we have this mercury. Then here at the anode here, the oxidation will take place, where we will have the chlorine ion, the chloride ion, the chloride ion, the oxidation where the chlorine is oxidized to the chloride ion. Sorry, it's oxidized to chloride. It should be, sorry, let me delete this one. Sorry. It should be vice versa. So here we have said the chloride ion, there is oxidation in this case, where the chlorine gas is oxidized should be, sorry for that. You know that the chlorine, let me repeat that explanation a bit so that you be, sorry. Should be, before you go to the question here. So what I'm saying, at the anode, there is oxidation. So here, at the anode here, there is oxidation where the chloride ion will be oxidized will be oxidized to chlorine gas. So we have two there. We have two here. So you will realize that this is oxidation of negative and this is zero. So this chlorine has been oxidized to chlorine atom. This is a gas, this is an aqueous. So then this one, the two electrons keeps on moving. It keeps on moving like that, and it comes to the anode, the cathode, I mean, where there is a reduction. At the anode, we know that the anode is now made up of the mercury because it has lower tendency. That makes it to be suitable. So there is a reduction. So to mean sodium ion is now combines with the two electrons to give us sodium metal. So this is solid, this is aqueous. So that is to give us two like that. So this one, the sodium has been reduced from 1 to 0. So then this sodium dissolves. It dissolves in the mercury. It dissolves the mercury here because now here also there is a gas, the hydrogen gas, which will also be formed here. I'll show you how it is formed. So this hydrogen dissolves inside the mercury to form what we call sodium, or not, it is called sodium amalgam. Sodium amalgam. Sodium amalgam, it means that the sodium has dissolved in the mercury. So it will be, so this sodium amalgam, then there is what is pumped inside here. At this point too, there is water. So this water breaks the sodium amalgam into sodium hydroxide, mercury, and hydrogen gas. So that is the mercury, the sodium amalgam, which is broken down. It is broken down by water, this water here, that water to give us the what is called the sodium hydroxide, hydrogen gas, and mercury. So the mercury, being that it is higher density, it is of high density, it will also dissolve down here. Then the sodium hydroxide, the sodium hydroxide will be now tapped out and collected at some point there. You can see it has been tapped out here, but it is 50% pure. It is 50% pure. It is not 100% pure. To make it more pure, it means we heat it to saturation to make it pure. Just like that, and everything will be okay. Now let us answer these questions. Name the raw material at 2. We said here at 2. Here at 2. Let me clear all these ones so that you'll be able. So here is 2. So the raw material here is water. We have 2. The main raw material, one is brine. Another raw material at the lower or at the cathode is what we call the water. That point. Then another question, name another material that can be used in the cell instead of the graphite. That can be even the carbon. You can use the carbon. Write an equation for the reaction that occurs at the anode, of which we have written, in which sodium hydroxide is produced. The equation in which sodium hydroxide is produced. So yes, we said that here, maybe we have not written it. It is sodium amalgam, which is sodium was dissolved in the mercury. Sodium was dissolved in the mercury. This is liquid now. And we used water to break this mercury, that is water, to break the mercury, which gives us sodium hydroxide, sodium hydroxide, which is now aqueous also, because it is solution, plus hydrogen gas. And being that hydrogen gas is less dense than water, it now trickle out. Let me show you before we proceed. So here with this hydrogen gas gets out. So here also we said we produced chlorine gas. This chlorine gas also gets out for other uses. Hydrogen gas also the same like that. Plus also mercury. Mercury, which is also liquid gas. Then we can balance. We have one nitrogen, one sodium, one mercury, two hydrogen. So we can write two here. So we'll have 4 hydrogen. Then we write two here. Then we have two here. Then we have 4 hydrogen, 1 oxygen, 2 oxygen. 2 oxygen, we can write 2 here. So now we'll have 6 hydrogens. So if we have 6 hydrogen on this side, we have 4 hydrogen. That is 4 plus, no, we have 4 hydrogen here already. Then I think it is now balanced. Like that, it is now balanced. Give one reason why the mercury is recycled. So the reason why mercury is recycled, because you know that mercury is very poisonous. So when it goes to the atmosphere, it can poison the living things, even the human beings. It's very dangerous. Then another question, the last question is, a current of this 1 amperes was passed through the cell for 5 hours. Calculate the mass of sodium hydroxide that was produced. Sodium hydroxide that was produced. So always we know that mass is given by RAM, or the relative molecular mass, times Q over the charge times 96 500 coulombs. So if you master this formula, then you will be able to get that. So let's see the RAM of sodium hydroxide, that is 23 plus 16, it will be 40. So we'll have 40 times Q. Q is I times T. I is the current, which is 100, times T, which is 5 hours. So 5 hours we convert it. We convert it to seconds by multiplying by 60 times 60, like that. Then we divide by the charge. The charge of sodium here is 1. So that is just 1 times 9,600. So you will be able to get the answer just like that. So you can compute that, then you get the answer. The answer should be in grams. Let's see how it works. So these are the questions. Has the higher negative part or loses electron most readily? Those are the answers of the questions that we have done. Just like that. It is water. So what can be used instead of, it can be platinum or titanium. Sorry, the one that can be used instead of graphite, platinum or titanium. So that is that. The equation was this one that we wrote there, which now gives us, or it can be this. So the one which is recommended is that first one. So thank you for watching this, and be blessed, and subscribe, because every day we'll be revising with the Form 4s, so long for them as they prepare for their KCSE examination. So subscribe, because the next one will be now aluminum. We'll discuss the questions, all the possible questions that can be tested under aluminum. Otherwise, thank you and enjoy.